Systems and Components 12. In question 11, you mentioned that the pressure axis of the PS diagram, pressure entropy diagram for refrigerant, wasn't exactly linear for R410A, causing you to pick high up between the 100 to 200 psia. On question 12 in the solution, you go right in between 100 and 200. I attempted to treat problem 12 with R134a like this by picking higher up the curve than halfway because of the verbiage in the previous video, and it wound up getting me to a COP of 4, unfortunately. Could you clarify how to correctly scale a point off of this nonlinear pressure entropy diagram? Is it pressure entropy or pressure enthalpy? Yeah, it's pressure enthalpy. So that should be pH, just to clarify. Yeah. But to answer your question, what I stated in question 11 is the correct guidance regarding the nonlinearity. I probably just glossed over it in the other one. But this is good, what I did here. So you can't see the 200 tick mark, but if it's between 100 and 200, if you only go halfway, you have to realize that as you go higher, it goes faster. So in the bottom half of the range, it's going slower. So if you only go to the halfway point, you actually haven't quite gone halfway yet. So the real midpoint is higher than halfway when you have this, I don't know if it's logarithmic, but it's certainly nonlinear vertical scale here. And then the question becomes, well, how much higher, right? Like obviously here I went higher than halfway point. You can see that just jumps off the screen. But did I go too high? I'm not sure. And I don't have any specific guidance about how to get that exactly right. I think you just have to, I mean, the difference honestly might be like the thickness of a pencil line. So it might just be close enough. And maybe if I went for the middle, I'd be a little low. One thing that you can try to do, if the problem will allow you to have enough other supporting information in the problem statement, is scroll down one screen and take a look at the table right underneath the chart and see if you have enough information to pick off another data point, you know, something specific based on that pressure, a temperature, something like that. Yes. Thank you. Jesse chimed in the chat and said exactly that. It's useful to use the charts to find the temperature under the curve. And since inside the vapor dome, inside the curved part, there can only be, if you know that you're in the saturated region in the middle and you have the enthalpy, you also can find the temperature. And you can do that using the table and then come back to here. And then once you find the temperature, you can just go horizontally over to the left and read off the enthalpy. So I think that would probably be a good idea, especially in cases where you're between 100 and 200. And this is a big area to kind of choose from. That would make me nervous too. Whereas if I'm choosing between like, you know, these are closer together. So if it's like 60, 65, honestly, the difference between 60 and 70, where's the middle of that? It's the thickness of a pencil line. So I'm not going to split hairs down there, but if it's a big space like this, then take a look at the table and try to dial it in. Yeah, fair question. And if I didn't do it in number 12 and I did it in number 11, then shame on me, but did I get away with it? I would invite you to kind of do it, if you are able to do it more precisely, either using the table or any other way. And, you know, tell me if our answers are far apart. I'd like to know.